What's up guys, it's Titus here with an introduction tutorial on visual scripting in Unreal Engine, or as it's more commonly known as Blueprints. It's a big topic, so let's dive right into our project setup so we can try and keep this video as short as possible. I'm going to be going with the third person template. Do make sure you have the starter content checked. Give it a name, choose a location, and then just go ahead and hit create. While we're waiting for that to load up, visual scripting at its core, it's basically just a node-based interface where you can design and create code without actually having to write a single line of code. So this is fantastic for prototyping, but you can also make full-fledged games in it as well. It's also easier to iterate gameplay and debug, at least in my opinion, on a blueprint setup. Versus something that's baked in C++. So if you've never written a single line of code, or you're not familiar with object-oriented programming at all, or its core concepts, then Blueprints is a great way to get introduced to it. And then of course you can move on to C++ as you get more familiar with Blueprints as well. There's nothing wrong. You can have mixed projects basically. Here's the starter game for third person. So we're going to create some folders starting off. First one I'm going to make is levels. Next one is blueprints. So this video is mainly going to focus on the common blueprint types because I haven't really found a good video out there that actually kind of explained the differences, at least for me starting off. So I was very confused. Basically, programming at its core is problem solving, and you can solve a problem many different ways. You can take different paths to a similar resolution basically. So with coding, you can write your code in lots of different places, but you may find that based on how it functions, it may or may not have the reach that you're looking for. And I'll kind of describe some of the of what I mean there. First things first, I'm going to make a new level. So file, new level. We'll do basic, and then I'm going to save it as level 1. Okay. I'm going to open up a graph editor just to cover the nodes first. So before we actually get into the blueprint types. So for the various types of nodes, we have event nodes. So you can do event tick. Event nodes are typically red. They're usually used to call or execute your code. This can be done through a collision event. It can be done through a keyboard input or a mouse input from the player. It can also be done through instantiation, or when an object is created, it calls an event to run some code. So there's lots of different events out there. Just know that they're typically red, and it's basically how you start your code. The other one is functions. Functions are typically blue and green. The blue functions are typically referencing or getting a value from the world, whether that's a transform or a rotation, a scale, or player controller, or what have you. Versus the blue ones, or blue nodes, those are typically changing a value, whether they're changing a rotation or changing a scale, or maybe they're playing in animation, or what have you. When it comes to blueprints, they're kind of, there's a lot of different types. Like you can have HUDs, you can do particle systems, you can do objects, of course, game managers, all sorts of things. So there are a lot of different types here. But yeah, so we got events, and then we got our functions. You also have your control nodes. They're typically silver. So branch, your for loops, flip-flops as well. So they're typically this kind of like silver grayish color. And those are like your if statements or your control statements, I guess is the best way to say them. So if you're running code and you need to put in checks or controls or gates, I think gate's actually another one, or sequence. Gate, and then sequence is another one. So they're basically ways for you to control the flow of your code. So very, very useful. You'll be using these a lot. And then of course you have your variable nodes. So on the left-hand side of this event graph, we can create a variable. Say we call call it health. When you create a variable, you can set a data type. If it's health, it's probably going to be a float. We create another one called death. Death is typically going to be a Boolean, right? You're either dead or you're not, right? When it comes to variables, you can drag them into your event graph and you can either get the variable or you can set the variable. And that's the same with our other one that we created. We can get death or we can set death. And these are useful as controls as well. So you'll be doing a lot of variable creation. Just be advised that this is a common look or setup for them. Other nodes that you'll see is animation nodes. Although I don't really want to get too much into that one, but I can see if there is one in, let's see, characters, probably mannequins, animations. It's Open Mani. So you have animation nodes in your anim graphs. So it's a little bit more advanced, but basically kind of harken back to visual scripting, right? So, or blueprinting. You're basically writing animation code through nodes. So that is possible as well. But back over here, you also have math operations. So like you can do a subtract, you can do a multiply or an add, greater than, less than, or equal. So your math nodes are typically, they look kind of like this. They don't really have a color. They're kind of just, you know, more ways for you to basically control your functions and stuff, how you're setting them up. Or I like to call them check nodes, right? Your booleans and stuff, what have you. And that's, yeah, basically all your nodes. You have your event nodes, your function nodes, your control nodes, your variables, your animation nodes, your math operations, or your check nodes, basically. So these are the most common types that you're probably gonna be working with here. But we'll go ahead and delete these. And let's delete these as well. All right, but going back to the blueprint types. So you got 4 common blueprint types. You got your level blueprint, which you saw we were just in. You have your blueprint class. So if I create a class, we'll choose class actor, and we'll call this one light. So this is your blueprint class, which has its own event graph. You also have your data only blueprints, which look like this. And you can see in the top left corner, data only blueprint. They're basically just like blueprint classes. They just don't have event graphs. So very easy to understand. And then you also have blueprint interfaces. So if I right click, go into interface, and we'll call this b_interface. And we'll cover blueprint interfaces here in a second as well. But yeah, so those are your 4 main types: level blueprint, blueprint class, data only blueprint, and your blueprint interface. I just realized I moved this in the wrong spot. There we go. All right, so let's cover the first type, which is your level blueprint. If you need to open your level blueprint, you just click on the blueprint icon at the top and do open level blueprint, and it'll bring you right here. So level blueprints are level-wide event graphs that cannot be created. Only one exists for each level, and there is no code reusability. So they're typically just used to handle level flow or control events or sequences, basically in or around that specific level. And by no code reusability, I mean like if you write some function or code in level 1, unfortunately, if you want that code to execute in level 2, you will have to rewrite it in the level 2 blueprint. So I'll kind of show you what that looks like. So let's write a basic line of code. On the event begin play, when this level starts, I'm going to tell it to print a string called hello for 10 seconds. I will compile and save, and then I will play my level 1, and then in the top left corner, you should see hello right there. Now if I go into level 2, which I have to create level 2, so if I create and then save level as, all right, level 2. And if I play level 2, my code doesn't run. And that harkens back to code reusability, right? If I go back into level 1, there's my code again. So the biggest takeaway for coding, you can write your code anywhere, but if you're writing it in a level blueprint, there's no code reusability, so you're gonna have to write it multiple times, so just be aware of that. This is in contrast to the second common blueprint type, and probably the most common that you'll run into, which is the blueprint class. So when you right click and you create a blueprint class, there are probably 5 main classes. I would say actors, pawns, characters, player controllers, and the game-based mode are the most common that you'll see. But if you hit the drop down here, you'll see that there are literally dozens. And I was kind of going back telling you, like, everything can be a blueprint, right? Your sound, your particle effects, your widgets, menu systems, HUDs, pretty much anything. So there's a lot in there, but your most common ones will be these first 5 up here. And knowing the type does kind of matter too. That isn't to say you can't make everything an actor. You could. You're just gonna have you're gonna find that when you try to do references to like a player controller, you're gonna have a hard time. So knowing the different types here can be helpful, and creating the appropriate ones will make it easier for you as well. But let's cancel here. I already created a light. Let's create some code on this light. So we want to add a light component. So I'll add a point light. And then I am going to go to my event graph, and when it begins, I'm going to tell it to delay. I'm going to wait 2 seconds. Then I'm going to get a reference to my point light. And then I'm going to set the color. So I will set the light color to be something different, like, let's do something crazy. There we go. And I will then set the intensity. Default intensity is 5,000, so let's just do 100,000. Why not? We can go pretty crazy here. Oops. All right, so, well, actually, I kind of do want to delay again, so let's drag off and do another delay, and we'll do 2 seconds. Oops. And then connect up our execution pins. Now you can select all your nodes and press Q, and it will center them. It's a handy trick. All right, anyways. Now if you absolutely hate how I have this set up, you can break the connections. This is driving you just absolutely crazy. Oops. And you could get just a second reference to your light and drag it in and do it that way. So you can organize your code however you want, basically. Some people are picky. But yeah, so now in our level 1, if I add my light in here, and there's code on that light, so if I play, in 2 seconds should change, and then 2 seconds more it should get very bright, which it does. And by code reusability, I can go into level 2, and I can add my light in level 2, and I don't have to write anything new. It's just gonna work. So that's code reusability, right? So knowing where to place your code, you know, I could of course write the same level. I can write it in the level blueprint. I would have to write it a second time, versus just writing the code once and then it's going to instantiate and follow in a blueprint class. So that's the advantage of blueprint class in general. That's also why it's the most common that you're going to see. It's very versatile. All right, but moving over past that, the next one that we're going to cover is called a data-only blueprint. I showed an example in the third-person blueprint, the game mode. If you wanted to make one, I haven't found a elegant way to do it, so I've been just making blueprint classes. And we'll just choose actor, and let's call this data-only BP. Now, obviously, when I open this up, this is not a data-only blueprint. It's obviously a blueprint class, but you can go to the construction script, delete it, and then save. And if you close out and relaunch it, you'll notice it is now a data-only blueprint. And if you needed to convert it back to a full blueprint class, you can. You just click right here. And of course, if you delete the construction script again, it'll bring it back over to a data-only blueprint. So data-only blueprints are basically kind of like what the name implies. They're just, like a series of values that you can reference or instantiate off of. That's why they're typically used for like game modes or inventory systems. They do commonly get confused with data assets, which are found in the miscellaneous tab. Here's the data asset there. There's a big difference between them though. I believe the data-only blueprints are runtime only, and the data assets are compiler build time. So what that means is your data set on a data-only blueprint is going to be only available when the game's running or the level's created, versus a data asset. The data is actually available at compiler build time, which means before the game's even started, it's available, or it's set or created. An example of why that might be useful, in a larger project where you have to dial in variables, it can be tedious when you're having to play the level and see how the object performs, like maybe you're adjusting the speed values or jump values or what have you. So you're clicking play, you're seeing how it acts, it's maybe not quite right, so then you have to stop the game, tweak the variables, and then play the game, and then test it over and over, kind of like that. It's fine if you only have a couple variables to do, or it's a small project. But in a larger project where you have maybe hundreds of variables that you have to test and dial in, structuring that in a data asset would allow you to play an editor or Pi. So you start up the game, you play it, and then if you don't like a value, if it's a data asset, you can go on the side without ever leaving the editor and tweak the value, and the change will actually be reflected in the game. So you can kind of dial in those values a lot easier if it's a data asset versus if it's a data-only blueprint. So there's advantages and disadvantages to both. So there's no right or wrong way. It's just whatever you kind of choose. There's best practices, of course, but yeah. So that's data-only blueprints. The last blueprint type that I wanted to cover was the interface, the blueprint interface. These are kind of odd because up until now, whether it's a level blueprint or a blueprint class, not necessarily a data-only blueprint, but if it's a blueprint class or a level blueprint, we've been creating the object, doing our function declarations, and then we're doing our implementation or our code all in the same object. An interface can be probably best thought of as a fancy dispatch system. So you're essentially creating the interface and you're doing the function declarations, but you're not doing any implementation. You're not setting up any code, which is kind of weird. Instead, you're going to set up that code on the objects you want to influence, and then just call that code through the dispatch system. So I'll kind of show you what that looks like. So we start off with a new function. I'm going to rename it. I'm going to call it function1, and I'm going to add another function called function2, and then another one called function3. Obviously use better names, but that's what I got for right now. So I've set up the declarations, but I haven't set up any implementation. So in our level example, we have a light. Let's create another class, and we'll call it b_cube. And let's add a cube component. Change the material. And yeah, that looks good. Compile, save. Okay. Oops, don't know why I pushed play. Okay, so we have a cube, and we have a light. Now I think for this example, I will use collisions because collisions are kind of easy to see and determine. Well, for visual anyways. So I'll put my cube out here, and we already have our light in the system. I'm going to create a third blueprint class, and it's just going to be a sphere with a trigger box or sphere. So b_sphere. Open that up. Let's add a sphere mesh. And on this one, I'm actually going to add a trigger because we want to do collisions, so we need some way to calculate that overlap. And I'm going to do a sphere collision, but I'm going to name it trigger. On my trigger, I am actually going to scale this up by 5 on the X, Y, and Z. So now you can see my mesh component and my trigger component are all in the same blueprint here. So what I want to do, or the problem at hand, is I want to go near a sphere, and I want that sphere to change the material of the cube and change the color and intensity of the light. And we can do that through a blueprint interface. So let's add the sphere over here, like so. Now, you can dispatch your interface from anywhere. You can do a message call from pretty much anywhere without, much work. You just need the interface to exist. Actually changing the code, though, requires some setup. So you would have to select your object. So let's go into our cube first. And we want to go into our class settings. And under the inherited interface, you'd want to hit add and select your b_interface, or whatever you named it, right? So we're basically telling this thing like, hey, I created this interface. I want you to load the interface so the functions are available. And when you do that, on the left-hand side, you'll notice you have access to function 1, 2, and 3. The problem is I haven't compiled and saved. So if I go to my event graph and I try to right-click and I search for function, I will get the interface message, which is the dispatch system. Because I've added the interface as inherited, I will also have access to the functions. But if you remember, there's no implementation on the functions, so they're blank. So that's not going to help me. I want the events, which I don't have. So if I compile and save, and now I search for function, you'll see I have the event functions. So we're going to create code for functions 1 and 2. Maybe if we have time, maybe I'll do 3. We're running pretty long here, though. Okay. So what we'll do is we will get a reference to our cube. We will set material to be something else, and we will connect up our execution pin. So for function 1. For function 2, we're going to again set material, but we're just going to choose something different, and then we'll connect up our execution pin. Now, nothing is going to happen. So if I push play and I go near this sphere, nothing's going to happen, right? And that makes sense, right? The reason being is because we've created the interface, we've created the declarations, we've created custom code to run on a blueprint class when that interface is triggered, but we've never triggered the actual interface. We never dispatched. We can only dispatch on, well, we were planning on dispatching on our sphere. So let's do that now. And on the sphere, I'm actually not going to add the interface. So you'll notice when I go to the event graph and I search for function, I have the message system, but I don't have the function or the event system. And you'll notice on the left here, I also don't have the interface showing. But that's fine, because you can dispatch an interface from anywhere. So essentially all we really want to do is call the function 2 and the function 1. How we're going to do that is on the event actor begin overlap. So we'll just drag off this, and we will cast to third person character. The other actor will be our object. And then I want to get all actors with interface. So I basically want to tell it, like, when my player gets in this this trigger zone, I want you to look for every single object with my b_interface. And then I want you to load all those objects into an array. So, you know, most of the time you're not going to know how many objects are in your interface, because there could be, you know, in our case, there's only 2, but there could be dozens or hundreds. So we're basically just going to get them all. And then from there, we're basically going to create a loop to cycle through each item in the array. And then we're going to tell whatever item is there, I want you to call function 1. So, you know, whether we only have 2 items, but if we had 10, 20, or 100, it's going to go through every item, and it's going to tell, hey, you know, whatever you are, call function 1. And then the next item, you call function 1. And then the next item, you call function 1. Now, what we also want to do is we can select our trigger, right-click, add an event for trigger, choose collision, and on component end overlap. So this is when it begins the overlap, and this is when it leaves the overlap. I can tell it to cast to third person character. I want the other actor. The reason I want other actor is because that's obviously going to be the player character, right? The other component, or the overlap component, is actually a reference to the sphere. So yeah, so basically if you want to get a reference to that, usually it's not necessary, which is why this one only has the 1. And then from here, we're again going to get all actors with interface, b_interface. And then we're again going to do a for each loop, go through each item in our array. But this time, we're going to call function 2. And this could, of course, be function 3 or whatever function you named it, right? Then I'm going to tell the actor to be in the target, and then the actor to be in the target here. Now, the reason this is interesting and cool is because we are literally doing a dispatch across multiple different blueprints, and the code that gets executed is going to be different depending on the blueprint. So under our cube, we're going to be changing the material, but under our light, we're going to be doing something else. So let's go into our class settings. We have to add in our interface, right? Because if I do a function call, I don't have the function or the event function. So I need to add the interface. Now I have the interface section on the left. You can see I have access to functions 1, 2, and 3. However, I still don't have the events, and that's because I did not compile save. So now if I do, event function 1 and event function 2. All right, so for this one, we are going to get another reference to our point light, and we are going to tell it to change the color. This time we'll go with green. And we will also set the intensity again. And we'll do 30,000. Hook up our execution pins. And I'm going to copy paste this. Hook up my execution pins here. And hook up my point light target, because I want it to do this code on the point light. And then I can press Q to center that. And that's probably good enough for me. So I'm going to change this back to, well, we'll do 500,000. And let's do blue. And no, let's do dark blue. All right, compile, save. Alright, so if I've set up my code correctly, you know, obviously the blueprint light is going to turn pink and get bright real quick because that's still baked in. That happens on event begin play, right? So that's a different event node. Now as I come closer to this trigger sphere, you'll notice the light turns green, cube turns whatever, concrete, and then if I leave, cube goes back to white and light goes blue. So that's pretty cool power of blueprint interface, right? So I use collision as an example. You don't have to do it through like a collision, or you don't have to modify actors in a game either. You can do it to change like inventory values as well. There's lots of things you can do. The example I like to use for blueprint interfaces is if you imagine you were making like a first-person shooter, you can have projectiles flying around on the map or the game, and you can create a blueprint interface for like an on-event hit. That projectile could hit a person, it could hit a car, and it could hit a tree. You still want the same on-hit event to happen, so you're coding it as an interface, but you want different functions to run depending on, or you want different things to happen depending on the blueprint or the object that it hits. So if it hits a player, you probably want to take away some life, and if it hits the car, maybe you want the car to explode. If it's the tree, you know, it probably doesn't need to do anything. But that's something you can achieve through an interface. You don't have to use an interface though. You could manually code everything, you know, on the actual, you can do it on the level blueprint, or you can actually do it on each one of the actors. You know, so it's pretty much however you want to set it up or configure it, but you know, that's just a basic rundown on the differences between the 4 main common blueprint types. So your level blueprints, your blueprint classes, your data only blueprints, and your blueprint interfaces. So I didn't see any videos that kind of cover this topic, so I kind of want to put one out there. So if you guys like this, or if you have any suggestions on other topics you want covered, just let me know down below. But otherwise, we'll leave it there. Thanks for watching.